Hello, everybody, and welcome back. Welcome back. We're still looking at our 2010-2011 year part 2 of the Alberta Math Contest, and we are on to problem 2. There's exactly one triple, x, y, z, of real numbers, so that x squared plus y squared is 2z, and x plus y plus z is t. So this is sort of the intersection of two surfaces in 3 space, but I don't think we're going to have to deal with that. They just want to know what's the value of t. So there is a value of t. So they say the definite article means there's really only one. There's a single value of t that we should be able to get so that there's only one solution to these two equations at the same time. Okay, what can we do? What can we do? Well, I suppose we could rearrange one of them, maybe the second equation, and solve for one of the variables in the other. The thing that stands out to me is this z. There doesn't really seem to be any advantage to subbing in x or y. They're basically treated the same, but this z is a little different. Okay, so we might say, rewrite x plus y plus z equals t, as z equals t minus x minus y, and plug in, so we get x squared plus y squared equals 2z, but now I've got 2t minus 2x minus 2y here. Okay, so t is some number. Now if we bring over our 2x's and 2y's, these two are basically, they are begging, please complete the square. And we realize, oh, this is just going to be a circle with radius t. Okay, that's kind of interesting. So if I add 1 to each of these, so I add 2 to both sides, I got 2t plus 2 over here. But now I can see, this is x plus 1 squared, and this is y plus 1 squared. And that's now equal to 2t plus 2, or 2 times t plus 1, whatever you want to say. Okay? So this is a circle, but circles have lots of equations. And, sorry, not lots of equations, lots of points. So if I pick a t and I get even the slightest radius over here, there's going to be lots of points, lots of x, y's that satisfy. And as soon as I have an x, y that satisfies this relationship, I can then find a z thanks to this formula. So I don't want a circle. Okay, well, what do circles look like? They look like a minus h squared plus y minus k squared equals r squared. So maybe if I don't have a square over here, negative numbers can't be squared. Well, if you do that, then you get no solutions. No x's and no y's will make this second equation work. And so there's no hope of getting any solutions to any of the equations. So we can't have that. But there is a special case called a degenerate circle where the radius is 0. And then you really just have 1 point. Okay? The reason this works is if you have 2 squares add up to 0, squares are always bigger than or equal to 0. So in order for them to actually add up to 0, they have to actually both be equal to 0, and that gives you a unique solution. X is h, y is k. Okay? For our purposes, x would end up being -1 and y would be -1. Okay? So get only one solution, to our new equation. It must represent a degenerate circle. You don't have to write this, you can just say, but I'm just adding it in. So 2t plus 2 needs to be equal to 0. We've got to have that. Okay? You don't even have to talk about it in terms of circles. You can just sort of use the justification that I verbally said over here. In order for two squares to add up to 0, both those squares must be 0. And then x and y will be 1. Okay? So from here, well, then 2t is negative 2, and so t is negative 1. That'll work. Now, just for the sake of completion, because this question didn't take too long, if we take t equals minus 1, x equals minus 1, y equals minus 1 are only solutions. To x plus 1 squared, y plus 1 squared equals 0. And so we can also now solve for t, or for z. So it was t minus x minus y. So that'll be negative 1 plus 1 plus 1. Z will be 1. So they didn't ask for that, but here we go. We've got the unique solution. Okay? So we've really double-checked that t equals minus 1 will give us the unique solution, and the way the question is worded, we know this is going to be the only t that works. We also proved it's the only t that's going to work, but we're just that much more confident, which is always nice for an exam like this. Okay, so up next we're going to be taking a look at problem number 3, and I will see you for that next time.